Okay, so as we start verifying or proving trig identities, as they say, here are the very most basic identities, that the cosecant is 1 over sine, the secant is 1 over cosine, cotangent is 1 over tangent, secant is 1 over cosecant, cosine is 1 over secant, and tangent is 1 over cotangent. Now, you should have, as you're doing your problems, an identity sheet that has all of the trig identities on it handy. So whether that's your notes or you have an actual printout with the trig identities, that would be a good thing to have. So as you're trying to work through these, you have those handy, because the tools we're going to use are the trig identities and some algebra skills, and that's what will allow us to do these problems. Okay, so these are the most basic ones. These are also considered some of the basic identities. Let's start over here. Tangent, I think we already know, is sine over cosine. We will use that a lot. One thing that might come in handy when you're working with tangent and you're trying to prove something is to change it to sine over cosine. And when working with cotangent, cotangent is cosine over sine. This is another one that is used a great deal, this set here. Cosine squared plus sine squared equals 1. That comes from the fact that when we work on a unit circle, remember, our cosine is our x value, our sine is our y value, and the equation of a circle is x squared plus y squared equals your radius squared, because we're centered at 0, 0. So that's where that comes from, but you don't need to know that. You just need to know this identity. Now, if we solve this identity for either sine squared or cosine squared, we come up with these next two, which also come up a lot. Sine squared is 1 minus cosine squared. And again, that comes from just solving this identity for sine squared. We would subtract cosine from both sides. And here, cosine squared is 1 minus sine squared. If we simplify even further and get just sine, we would do that by taking the square root of both sides, which leaves us with plus or minus square root 1 minus cosine squared. Why the plus or minus? Well, remember, when something is squared, if it's negative, it would come out as a positive, and if it's positive, it comes out as a positive. So we have to account for both of those. So these last two come just working a little further, took the square root of both sides to get this, took the square root of both sides here to get this. And again, we have to put that plus or minus in front to ensure that we took care of both possibilities. And here's our final set. 1 plus tangent squared is secant squared. Now, some people like to write down next to that that would mean that tangent squared is equal to secant squared minus 1, okay, and that cotangent squared is equal to cosecant squared minus 1. Some people like to have those there because you may need to use those at some point also. Okay, so there are our basic identities. Again, you'll want to have those on either in your notes or on a sheet of paper. So as you go through the identities, you can use them. Let's go a little more in depth on why we have the plus and the minus, and the plus and the minus here, and for which values would that come into play. Okay, so for what values would the sine of theta be the positive, the square root of 1 minus cosine squared? Well, remember on our unit circle that we use, we had places where sine was positive and where sine was negative. Now remember, for a given point, the sine is the y value. So it would be places where the y value is positive. Okay, so that's where this would come into play. That's why we have positive and down here a negative. Okay, that's because some places sine is positive and some places sine is negative. In the top of our unit circle, remember our sine is positive in the first quadrant, and sine is also positive in the second quadrant. It's negative in the third quadrant and in the fourth quadrant. Remember, that's because sine is the y value of a given point. Y values are negative down here and positive up here. So when would it be, for what angles would sine be equal to the positive of the square root of 1 minus cosine squared? Well, that would be for any angles that are in the top here. So angles between 0 and 180 degrees, or between 0 and pi radians, depending on which you're working in. So when theta is between 0 and 180, okay, so like the angle 45, that would work. For the angle 160, this one would work. But when we dip down here into, say, 200 degrees, that's not going to work anymore. Our sine value is negative, so that's what this one is for. Okay, that's why we have the plus and the minus, so we cover all the values. So for what values would sine theta equals negative root 1 minus cosine squared would work? Well, that would be for angles that are down here in quadrants 3 and 4. So that would be from 180 to 360. Or again, if you're working with pi, that would be between pi and 2 pi. All right, what about our cosine? Okay, well, if we look at our unit circle for cosine, for what values would cosine theta be the negative square root of 1 minus sine squared? Well, that's when we would want a negative result. So that would be the quadrants in which cosine is negative. Cosine is the x value of a given point. So it would be negative wherever x values are negative on a graph. So on our unit circle, it would be quadrants 2 and 3. That's where cosine is negative. Okay, so this would be appropriate for from 90 degrees to 270 degrees. Or if you're working with pi, pi over 2 to 3 pi over 2. So that would mean that positive cosine being positive square root 1 minus sine, would happen on this side of the graph, this unit circle, okay, where our x values are positive. So that's quadrants 1 and 4. Okay, so that would be from 0 to 90 and from 270 to 360. Okay, we could also describe it as angles from negative 90 to positive 90 if you prefer that. Right? But that is why we have both the positive and negative, so that we're able to cover all those values. And notice that the positive doesn't work in all 4 quadrants, the negative doesn't work in all 4 quadrants, and it depends on whether you're working with sine or cosine.